Hello guys, welcome back to another tutorial. Hit the bell icon button so that you don't miss out any tutorial.
So in the cloud, you have so many different places to put your data, but where does it go? What are your storage options? So let's talk about the different storage options that are out there and the various different use cases that we have for them. The first thing that always comes to my mind when I'm thinking about storage is raw files, videos, photos, audio, large documents. There are tons of different types of files out there. And when you need to just store the raw file, databases don't really make sense. So there's cloud storage. This is very analogous to AWS's S3, and they even call their storage units buckets. Cloud storage has several options and is very cost effective. However, it's not always necessarily the best when you're talking about working with operating systems, and sometimes you want a much faster and more performant version of a bucket, which would be a compute disk that's directly attached to a compute instance, a virtual machine. So for instance, if you want to have a solid state performance, you can attach a solid state disk directly to a virtual machine, where if you're using the cloud storage option, you're not going to have that raw horsepower of I/O, of reading and writing. So you're going to want to figure out what your use case scenarios are around it. For instance, if you're doing something around AI and you want to access a data file, you're definitely going to want to be using something like a compute disk. However, if you just want to store a photo for a website, cloud storage may be much better because you can distribute it internationally. The next thing that always comes up in storage is data and using databases. We have several options in here, and the first one that is more classic than anything else is SQL-based databases. And Cloud SQL supports both MySQL and Postgres. These are two of the most common and powerful open source platforms for SQL-based databases that are out there. Other ones like Oracle or SQL Server can be run on top of compute, however, are not supported by Cloud SQL. And no discussion about databases today would be complete without a discussion of NoSQL-based databases. And Google, no surprise, has an amazing one. It's called Data Store. It's very similar to AWS's DynamoDB or MongoDB, if you're familiar with either of those two offerings. And for you data scientists out there are crazy big data options. These are a little bit beyond the scope of this course, so we'll be going ahead and just talking about them briefly. The first option is Bigtable. This is used to query very large data sets using standard SQL options, while Cloud Spanner is more of a columnar data set that allows you to do date-ranged queries in a much more performant manner on insane sized data sets. Speaking of insane sizes, really, unless you're in the terabyte and petabyte range, these options are not going to be best for you. Typically speaking, if you're under these options or under these sizes, the options of MySQL or Postgres or some kind of NoSQL based solution or even file based solutions are going to work out much better for you. And just like with everything in Google, there's a lot of different ways to connect to things. We're going to be connecting with APIs or custom protocols such as SQL. For instance, if you're talking to a SQL-based Cloud SQL instance, you would just use SQL just like you would on your local development machine speaking SQL, or if you'd installed a SQL server on a compute instance and we're running it as a self-administered system. And of course, the last option is going to be directly from the operating system. This is going to give you the most performance, especially when you're talking about compute disk type instances, and is really going to be required for running any modern operating system at all. However, Docker containers and stuff like that have started to favor things like cloud storage because it's a little more portable and easy to connect to from a Docker containerized instance, whereas hard drives and disks need to be hooked up to specific instances. And while this can be accomplished in things like Docker and Kubernetes, it's a lot easier to just work with cloud storage. So we'll be going over each of these options in more detail, but I kind of wanted to give you a high level view where raw files might go, where you might put your raw data, such as user records or things like that, and where the crazy big data stuff is going to go. So with cloud storage and buckets, there are so many different classes of storage and so many little things to take into account. I thought I would do a brief chapter on just the different classes of storage alone so that you can make the right decision when picking your bucket storage class. Alright, so let's talk about the 4 different storage class options that you have. The first one is multi-regional. It's the most expensive and it's the most performant, but it's also the most expensive. The next one down and slightly less expensive is regional. And this one has different use cases that we'll get into. The next one down starts to get into the more backup and long-term storage area, which is nearline and is cheaper still. And the cheapest amongst all of them is cold line, and this is really for your real long-term disaster recovery type scenarios. So let's talk about each one of these real quick independently. The first one is multi-regional. Let's talk about some of the use cases for this. If you have items that are going to have frequent access, whether it's read or write access, this is a good choice, especially if your access is all across the globe or multi-regional. So for those of you with a larger world audience, this is going to be a good use case for you. Things like website content really benefit from having multi-regional storage options. This way, if someone is in Australia and requesting your website and there's just an image that needs to be downloaded, it's in Australia as opposed to having to go all the way to, say, Ohio. Another excellent use case for this is streaming video. And when you're building a game, of course you're going to need the performance, especially if this is some type of real-time or near real-time game. And even more so if your game is on mobile. However, mobile content also benefits greatly. Google has paired up some of their data centers with some of the mobile providers, allowing real high-quality access in top-tier peered networks. And as we discussed, it's definitely the most expensive option. However, you can see why. It offers a lot more performance by distributing your content all over the globe. Next, let's talk about regional storage. Regional storage is good for access by your system, but not necessarily by your customers, unless you have customers that are limited to a specific region. However, this is a very specific use case and not usually one of the ones you're going to be considering. So this makes it really good for internal storage of items. For instance, if you have a large image index that you go through once in a blue moon and reprocess, these would be needed to stored only in one region, and you would likely have compute resources there that process them inside that regional area so that they didn't need to be transmitted to a different region of the Google Cloud. Sometimes the cost-benefit analysis will tell you it's better to use this regional system even if you need to distribute some of these resources more globally. And those will be non-time critical, low access resources. For instance, if a file only needs to be read once every 6 days and it's only going to be accessed that one time every 6 days, maybe regional storage is a better choice. And if all of your compute resources are in a single region, regional access means it's going to be fast for that region and not necessarily fast for other regions, but that may be all you need. And remember, other regions can still access it, so it's not like you're pigeonholing yourself in, and you can always upgrade your storage class or take it down a notch. Just it depends on what you need, and your needs will change as your applications grow. So this is just one of the many options you can choose. And it's definitely cheaper than multi-regional. Often my development systems I set up as regional systems because I will develop inside of the region that's closest to my development position at the time. So for instance, right now I'm in California, so setting up a California system and using regional storage there is better for development and cheaper for development. But when I deploy my systems, I will usually deploy them globally so that everybody can have high availability access to my systems. So let's talk about the last two options in tandem, nearline and cold line. They're both long-term storage options, but they do have different use cases. The nearline one has a 30-day minimum usage fee and is very cheap, but not the cheapest. It's very similar to a sustained usage discount, and the use cases for it tend to be centered around backups, where you're going to be holding on to files for a very long time, but you'll need to have, relatively easy access to them. And situations where you just need long-term file storage. For instance, if users are allowed to upload videos or photos to your system and you want to just keep them around for a long time, you might as well get the cheaper cost of it. Cold line, on the other hand, is really centered more around the absolute bare bone cheapest way to go. It has a 90-day minimum usage fee though, and it's the cheapest of all the options, but you will pay to recover the files. So the use cases around cold line are most often centered around disaster recovery, where you would only need to access these files under the rarest of circumstances. This makes for a nice way to store files you may one day need and keep it cheap. So for a quick recap, remember we talked about the 4 types of storage and how the cheaper ones are not necessarily good for all use cases, but the expensive ones don't match all of the use cases either. So expensive ones have more features, better performance. However, the cheaper ones are good if you're not going to be accessing your information all that often. And remember, there were 4 tiers. The most expensive tier is multi-regional and good when you want your data completely global. And the cheapest one has a 90-day minimum and a cost to actually access your data. So it's best only to use for backups and very disaster recovery intensive plans. The other thing we talked about already is the gsutil command. It's the command line tool for moving files around. However, we'll see that that's not its only use here, as we'll be using it to unlock some of the features for our buckets that can't be done inside of the console. There are some things we can't do with gsutil, and those are handled with gcloud as we talked about earlier, so we won't be going over too much of that right now. And as I mentioned, not everything is supported in the console. This is really important to understand because sometimes the most powerful features are first implemented on the command line and then later built into the console. One of those features is versioning. Versioning is a very, very powerful tool that allows you to keep every version of a file that's ever been uploaded to a bucket, if that's the policy that you want to create. It allows you to make sure that you never have the chance of losing any data whatsoever. You can go back and get something, whether or not it's for a backup because malicious content attacked your website, who knows. However, it's super powerful and it can only be accessed on the command line right now. So in this video, I'll show you how to turn it on, set it up, and retrieve an old version real quick. One of the other things that's in here that's pretty cool too is retention policies. Retention policies actually give you the ability to prevent a bucket from being deleted or prevent files on the bucket from being deleted within a certain time frame. These retention policies can help add to compliance factors, especially where government, medical, or banking laws require that you hold on to a file for a specific period of time. You can even set up the retention policies where you, the account administrator, couldn't even delete the file if you wanted to, making it truly fully compliant, where even you can't violate the policies that you set forth on your own. So let's go ahead and open up our Google storage. It's over here on the left, about halfway down or so. And this will bring you to all of the test buckets or buckets that are in your system for your project. In my case, you'll see 2 test buckets. Your buckets are going to have different names. And remember, just to recap, every bucket has to have a unique name. So no 2 students or no 2 professors are ever going to have the same bucket. So I want to go through the process of creating a bucket, so we'll go ahead and click Create Bucket. Nothing here is too crazy, but what I do want to show you is some of the more advanced settings. So we'll go ahead and input some of this information rather quickly, and I'll go ahead and just add a 2 to this. And I'm just going to use regional here because I don't want to pay the extra fees associated with these for retrieval, and I don't need the best performance. However, I am going to switch this into the area that I'm using, and I suggest that you do the same just so that you can have some consistency with the speed of access. For instance, I'm using US Central 1 for everything I do in this course. We'll go ahead and click Continue, and it'll take us down to the ACL model. There are 2 types of access control, but first let's talk about what an ACL is. It stands for Access Control List, and what it means is, how is your object allowed to be accessed? Have you given permissions to another account? Have you given them to a user? Is the object public? These are all the questions that the ACL will answer for you. During development, I've found that there are lots of different use cases. Sometimes you want a very tightly controlled and very private bucket to store internal and very mission critical information. And other times you're setting up a bucket so that you can put website files that anyone can download, and in fact you're hoping that a lot of people download. So different access control models will exist, and you can often use several buckets to implement the various different roles for these buckets. However, that's not what we're doing here. What we're doing here on this particular step is choosing whether or not we set permissions on a single object or on the entire bucket uniformly. So the option I like to choose whenever I don't need really granular control is setting my permissions uniformly at the bucket level. I tend to find that this is the best one because most often I want to treat everything in a bucket the same way. For instance, if I'm building a website and I want to publish it in a bucket, this is a great access control model because everything I put in that bucket I should assume is public. And I don't want to be confused when I'm putting something up there or having to adjust the permissions on a file by file basis. However, let's say I was building a file management system for my users. I might want object level permissions so that I could utilize Google's cloud to handle my security for me and allow my users to share information between them. So setting the permissions at an object level is actually a very powerful way to handle that, and would be a nice way to ensure that my security is being handled by Google's cloud as opposed to my own code. I'm going to set it at object level just so that we can go over all of the various little bells and whistles that Google Storage offers us, but I do encourage you to set them uniformly at the bucket level if possible. So we'll go ahead and continue on to the advanced settings. The first thing we have to always pick is who manages our encryption. Is it going to be us managing it, where we provide a key to the Google Cloud, or are we going to allow Google to manage it? Oftentimes, just allowing Google to manage it is going to be your best choice. It prevents you from ever having a problem decrypting your information. However, a lot of times in more advanced systems, you will have very strict key requirements. So the customer managed key is also very appealing to a lot of customers. Your use cases will dictate which one of these you pick. However, if you're not concerned with managing your own key, Google will do a great job of it. And one of the nice things here, like I said, is you'll never accidentally lock yourself out of it. So there's a lot of advantages there. The next thing we're going to want to do is set a retention policy if we want one. If you check this box, it's going to show an additional number of items. So for instance, you can say that I want to keep all objects for at least 7 days. This will make sure that no item is deleted within 7 days. This might be beneficial for debugging a system, or perhaps it's just part of your use case. However, oftentimes this is more a matter of compliance rather than implementation. So I'll go ahead and leave this at 7 days, and then we can add labels if we want. Labels are nothing more than key value pairs that help us organize things. For instance, I can say, is this a test bucket? And then I can add the value of true. Later, when we're using the command line, I could say scan through all buckets, find all the buckets that are test buckets, and assign them to a cheaper tier so that I could be more macroscopically setting all of my test systems to a cheaper service level, where all of my production systems go to the multi-regional level. This is just an example, of course. You can use the labels for anything you want, and as you can see, you can have multiples. The last thing I'd like to take a look at is the cost calculator over here on the right. It gives you a way of estimating costs. Oftentimes, clients or your boss will ask you, hey, after the system's been up for 6 months under these usage conditions, how much will this be costing me? Google offers a lot of cost calculators, and they're all very powerful. This one is specific to the storage platform, but I think it's cool because you can say, if I put 10 gigs in here, and I want to be retrieving 50 gigs, meaning each of those files 5 times, and for operations, I want to make 50,000 Class A operations and 100,000 Class B operations, which are just the various types of accesses you can do. Like if you want to retrieve the file, it has to work on the hard drive, and that is what's called an IOP, or what they've said here for short is OPS. So that has to do with the amount of data you're accessing. And Class A versus Class B has to do with whether or not you're creating a bucket and uploading an object, or if you're downloading an object or viewing the metadata. Here is an example of the operations and what they are classified as. And then down here we can see, even with storing 10 gigabytes, accessing it 5 times, and doing all kinds of operations on it with a nearly unlimited SLA, we're only going to pay less than half of a penny per month. So with that, we don't actually use any of these details when we save. So when we click create, whatever we typed in over there is just separate from that. So let's go ahead and create this bucket. And it doesn't take very long for it to create. So here we have our bucket, and we've already gone over using gsutil to upload a file and bring it back. So I'm going to show you a slightly different way of doing that now. So here I have those files that we worked with earlier. So I'm going to take this central dev and upload it to the server. I can just drag and drop it over here, and it'll actually automatically start the upload for me, and it'll name it based on the file name that it was on the original computer. So that's very useful. This certainly isn't a replacement for the command line. However, if you are working with files in a more visual way, this is actually a preferable way to do it. However, it lacks the automation that you can bring with the CLI. And remember, there are a number of ways that you can access the command line. The other way I could do this is by just clicking on this Activate Cloud Shell button, and this would give me a command line as well. So it just depends on how you want to do it. I'm going to use the command line for this one, but feel free to use whichever one you prefer. So the first step, and these are the steps that are included in some of the documentation links that I provided below. So if you want to copy and paste them out of there, that's an excellent way to do it. And also you could follow along from there as well. So the very first thing I want to do is turn on the versioning for this specific bucket. So we're going to use gsutil, and we're going to use the versioning command here. So remember, the structure is, this is the operating system portion of the command that says, go use this executable file. And this is the part of the command that says what you want this to do. often referred to as a parameter. And then we'll go into subparameters or subcommands as they're also sometimes called. So the next thing I want to do with the versioning is to set it. And in this case, you can set it to either on or off. And in my case, I want to turn it on. And then the last thing I need to do is add a bucket URL to it. So this is pretty much just gs:// your bucket name. However, if you have a crazy bucket name, perhaps it has a UUID in it or something that's very difficult to type, you can also use this overview tab to get a link to it and just click here to copy it. So we'll switch back to the command prompt and now we'll go ahead and paste it in. So this command here will turn on the versioning for this specific bucket. Okay, so we'll let that run, and while it's running, I'm going to tell you that I'm expecting a problem. I've turned on the retention policy, and that's incompatible with versioning. And here you can see the error that we're getting. So sometimes features inside of the Google Cloud will have exclusivity, meaning you can't say have a retention policy and keep versioning around, because by its very nature, to version something, you would have to change it, and if it has a retention policy, it's going to conflict with that and prevent you from changing it. So let's go ahead and go back to our bucket and turn off our retention policy for now. We'll go ahead and click on this bucket lock, and this will take us to the page where it talks about the retention policy. And you'll notice that there's a little delete button over here, and we're going to want to go ahead and click that. And then this will allow us to delete it. And now, if we go and run that command, we should be okay. So we'll go back, and a little helpful tip in case you didn't know it is if you push the up arrow on Mac, Linux, or Windows, you'll get the last command that you ran, and we'll go ahead and run it again. And there you go. So now what I'd like to do is take this central dev file and re-upload it, but I'd like to upload it with some changes. So I'm going to go ahead and change it. And instead of making you watch this, let's go ahead and pay attention to its size. Right now it's 13.1 megabytes, and I'm going to go ahead and edit it right now, and we'll just use some video editing magic to take care of the details. And there we have it, a super tiny file to replace our other larger file. Now, I happen to have a copy from when we worked on this earlier, so I have this ASDF in case I want it back. But I think the important thing I want to go over here is that we can now upload this over here to objects. So I'm going to click back to the browser and re-upload this. So I'll go ahead and just drag this into here, and it'll go ahead and ask me if I want to replace the existing object or skip it. So I'm going to replace it in this case because we want to test out the versioning. And you'll notice that it uploaded very quickly, and now our size is small just like on our hard drive. So now let's take a look at some of the ways we can use the command line to view the history of this file. So here I am on the command line. Now let's take a look at a rather standard command, which is ls, which if you're familiar with Linux or Mac means list. So this is a way of saying list all of the files in a bucket. So let's go ahead and do that. gsutil ls and then our bucket name. And here you'll see that it returns just a single URL, a GS URL, and it's going to point to our file. So if we wanted to program and get the most recent version of our file or retrieve the most recent version of our file, that URL would work very well for us. However, we turned on versioning, so there's actually two versions of this file. So the way we can do that is by passing the -a parameter in after ls. So again, I'm going to use my up arrow to bring back my information, and I'm going to add -a and hit enter. Now here we'll notice that the same URL was returned twice, and there's this hash sign at the end with a very long number. This very long number is the version of our file, and it will go up over time. It won't ever go down, but it will never be the same either. So these refer to the various different versions of the file. So if I want to download one of these specific versions, I need to use a command to get that specific version and use the hash part of the file name. So just like when we copied it earlier in a different video, we're going to use the cp command. However, what we do now is we add the hash mark in there and the version number, and now we can retrieve the specific version that we want. So just to prove that it works, I'm going to show you the file size that we have. And here it's 59 kilobytes. So the original one was over 13 megs. So when we return this earlier version, we should see that it returns back to the 13 meg size. So let's go ahead and type our command, gsutil, cp for copy, and then I want to copy this version of it. So I'll go ahead and use copy and paste inside of the browser, or rather the command line. And then I want to copy it to the temp directory, and we'll just call this recovered file.sql and go ahead and hit enter. And when we do that, what we'll see is that the file gets copied down from the server and that it is the original 13 megabytes that the original file was. So we've gone back and gotten one of the previous versions. Now, if we were to run that same command and use the more recent version number, we would get the newer version of that file. So we could type gsutil cp. Again, we can use the version number here for our cp command, and then I can go ahead and say recovered file newer.sql. And when I download this one, you'll notice that it downloads very quickly and is small, just like the current version of it, because it is, in fact, the current version of it.
Thank you for watching. Don't forget to subscribe to the channel. If you like the video, do give us a thumbs up and share it. Also check out amazing discounts and offers on our premium courses in the description below.